Hello all, I am very happy to have the opportunity to share with you my experience in using Mydas Engine. My name is Richard Kofi. I'm a structural engineer. I have a PhD in structural engineering and I have been using structural analysis software for well over 25. I want to say that in this time of COVID-19, let us keep safe. Let us stay at home if we have it locked down. And please be careful. I will start the presentation. The presentation is going to take two forms. I will do a general presentation talking about the advantages and the future prospect of Mydas Engine as a next generation one-stop solution for structural engineers, my experience with Mydas Engine. And in the second part, I will be very happy to share with you some few tricks and what actually makes Mydas Engine stand out as the structural software for the future. So let me introduce myself once again, a bit of a background. I have used several structural analysis software for the past 25 years, and this will include STAAD, Robot, CSI, SAP, Orion, Prota, ETABS, and Mydas Engine, which is also from Midas. I have had the opportunity to offer training to several engineers and students in computer analysis of structures using Bentley STAAD, mostly in Accra, Ghana. So what do I have to say about the past experience in using computer software and structural software programs? Well, most of this software are powerful and packed with features. Yes, you can model and analyze any structure, but sometimes it's with such difficulty that you might just give up. I'm quite okay, very adept in using software generally, but even I have given up on a few software because the user-friendly, it's not really user-friendly at all. And what happens is that modeling a structure will demand too much preparatory works, coordinate calculation, and cracking of your brains, a lot of it. So my recent experience is I was introduced to Mydas Engine in March 2019, and I can say without doubt that it's truly the next generation software available for us practicing engineers in this generation. Why is Mydas Engine so different from others? It's very easy to learn. Actually, if you use AutoCAD and you remember the basis of structure analysis, which I think we all do, then you already are about 60 to 70% into the learning curves of Mydas Engine. Mydas Engine is so versatile when it comes to modeling. You can copy, you can extend, you can trim, you can stretch, rotate, mirror, split, array, divide, and auto-edit structural members. I mean, beams, columns, slab, foundation, etc. with just a single click of a button. It's truly amazing. And what's good, you don't need any grid lines. So the members don't have to be attached to grid lines for them to be moved, stretched, etc. Forget about coordinate of nodes. You remember your normal finite element analysis programs where you definitely have to talk about nodes, member connectivity, beta angles. Forget about it. Forget meshing. Mydas Engine got all that covered for you. We just model with physical members. Yes, physical members. When you are modeling a Mydas Engine, we don't talk about members and nodes. We talk about beams, columns, foundations, etc. So Mydas Engine has been organized in such a way that with minimal effort, any practicing engineer can model, analyze, and design structures easily, intuitively, efficiently, effectively, and very quickly. The learning curve for Mydas Engine is the easiest I have come across. So model generation is very quick. You can actually create a model using grid lines. So you just draw your grid lines and then you convert them to beams, slab, columns, etc. This screen shows how that is done, and you look at it. So right here you see convert into member. So we got this grid, convert into member, and then these forms. You can also import AutoCAD 2D and 3D files directly into Engine and convert them into beams, columns, slab, plates, shelves, etc. And you can use AutoCAD like command to draw members right inside Engine. So I can take a beam, and when I draw, I just move to the right, and I type the distance, just like you do in AutoCAD. Now, nGen has something very unique. It's called body. So this unique body feature of nGen can be used to generate model very quickly and easily. So I want to talk about some awesome features of nGen, and as they call it, the new paradigm of effortless modeling. So there are 3 modes of working seamlessly in nGen. You have the 3D mode, the plane mode, and the story mode. So the 3D mode is the default mode where you model everything in 3D. The plane mode is when you want to just take a plane and model it, and the story mode when you have a story building and you want to go story by story. It makes it very easy. You see it during the demonstration and maybe some of the previous webinars. Now, creating a work plane in Mydas Engine is simple as clicking 3 points in space. So 3 points defines this plane. You can click 2 non-parallel edges or on a plane and many other options. The body feature I talked about in nGen is like having an Autodesk Inventor, which is a full-fledged 3D modeling program software by Autodesk, or Rivet right inside the program, because it features advanced 3D modeling tools like revolve, sweep, extrude, shell, loft, etc. With this tool, creating spectacular models, as I call them, very complicated model, is very easy. Now, analysis is blazing fast. The analysis engine is very powerful, very fast and accurate. It's a true 64-bit solver, and it can use up to 20 processing core of your CPU. With even a memory of 4 GB, a 15-story building can be analyzed in minutes. So, well, I asked the question, what does this mean for our structural engineers? Well, more time to try out different configuration, and yes, sure, some more time with the family. So here you can see what type of solver they have, and then some other options. Great, very great. Now, this is another class for Mydas Engine, how it displays analysis result. It's another incredible feature of Mydas Engine, the way analysis and design results are displayed. In my experience, no software can come close to how nGen vividly and visually displays result of analysis that's performed. The result of deformation is shown in true 3D. So you can see some other software, and I'm sorry to say, but they can show you only the deformation in just lines. The members, the beams and column are just lines. You can't see them in the true 3D model. And the displacement can be displayed in 7 different directions. If you add 4 distinct rotations, you get a total of 11 deformations. Most of the software do 1 or 2, and also that is not even in 3D. So the display is in the complete XYZ direction, individually in the XYZ, and also in the XY, XZ, and the YZ planes. So you can see them right here. So I can see displacement in the XYZ, displacement in the X, displacement in the Y, in the Z, rotations, and so on. Now, this makes result verification very easy. So this incredible feature in nGen makes it easy to identify and correct errors in models. So you do a model, you are displaying your result, and immediately it is very, very clear where you have an error in the model, and it helps a lot. Because normally verification of results, engineers are on their own here. So with the way nGen displays the result, and you can immediately see where your model is faulty, generally this is good, and I really like this feature. Thank you, nGen. So what else? The graphical presentation of the model data, the analysis result, and the design result depict clarity and understanding. The way the graphics is presented, everything is clear, concise, and it's like close to real. So as you can see here, you can see a model, see the slabs. This is a flat slab with it's a flat slab, and then the model is really very clear, in my opinion. This is the analysis result, where you are clearly seeing the meshes, the deformations, which is very clear, and anywhere there might be some mistake, it will be clear for you to see. So what you see here, it shows you the range of deformations in this particular case. So this is the displacement of XYZ. This is the displacement of XYZ. So you see in your flat slab, you see in the flat slab section, you can see your moment and well, almost everything what you need to get from your analysis result. The design result will show you which members are okay, which members are critical, and which members are not good. So in this particular case, we can see that most of the slab here are okay. The flat slab portions, they are okay, but these portions are not. This column is critical, and some of the beams are also critical. In this particular case, after adjusting the reinforcement, you see that everything has passed. So this is what you would normally want to have as a result. So you go through some iterations with the reinforcement, and then you can get the required result. Generally, I think Mydas Engine can be used as a tool for learning. This is because the engine graphics are stunning and almost realistic. The graphics are comparable and in fact surpasses many well-known 3D modeling software. This makes it very suitable as a learning tool because deformations of structures under loading is simulated almost precisely in the chosen scale. And I recommend educational institutions to adopt nGen as a preferred structural analysis software because the visuals are good and easy to understand. As an example, I will investigate the buckling of a column under different boundary condition, and then on the screen you see 3 concrete columns modeled, length 20 meters. The size of the column is 800 by 1200. This one has fixed support at this end and is free here. This has a pin support at both ends. This has a fixed support at both ends. We are coming to investigate buckling effect. Note that all this can be done in one model. So we model 3 different structures in a model. I just ran my analysis, which is actually the linear buckling analysis. Run analysis, and the analysis runs very fast. I'm actually doing 30 modes. After that, we can investigate the results. So I just go to my displacement, I choose deform, and I can check out my modes. So you can see the modes. This is actually showing the buckling loads. So you multiply the eigenvalue by 1 and you get a buckling load. You can actually animate each buckling mode step by step and step through. So as you can see, the free end is the one to buckle first, and it's buckling in both first in one direction and in the other direction. This is the one with both pinned end, also showing the different directions. Then the one with the free end buckles again. This is the second mode for the free end, the third mode actually. Now the one with the fixed end shows the deformations. So you can actually go through all that and see. And this is a very great tool for learning, in my opinion. Really very great tool. I run through them fast. Like I said, it's 30 modes, but of course it shows for each particular fixed conditions, fixed support. So you can really play with this to investigate. The clarity of the animation is really very good, and it shows everything clearly. This can be a great tool for learning. Really very helpful. Okay, so here we look at some more incredible features in Mydas Engine. I hope you remember sets as we did in school. So Mydas Engine comes with load set, boundary set, member set, story set, mass set, and stiffness set. So this story set will allow you to model, analyze, and design different towers inside the same model, even if these towers are not linked in any way. The load set will allow you to, on the same structure, define different load conditions and analyze them separately. Member set will allow you to include members in your analysis, exclude which members you don't want, and so on. Now the mass set will allow you to define different load to mass, and boundary set will allow you to define different support systems. So in nGen, this feature enables you to easily analyze and design a single structure model under different conditions in the same file, and this is truly an awesome feature. More awesome features are you can open multiple files in the same session. Same nGen session, you can open multiple files and then you can compare them. You're able to analyze different structure model in a single model file. It means if you have 5 models in a single model file, in a single model file, all you do is you analyze, and then nGen will analyze each of them, and then you can only analyze just a small part of a structure in your model. I'll go on to just talk about my projects which have used Mydas Engine to design. So normally this is from architecture drawings to structural drawings, and also to 3D printed models, which is something amazing for me, and which is something I know is futuristic and it's coming up. I mean, we will just see how it works. So everything is automated and optimized, and then the report generation provides a multidisciplinary and fully integrated solution for structural design. So this is a project. This is the architecture model which the architect delivered. You can see it's really done nicely. I'm sure it was done in ArchiCAD or something like that. And well, this is the structure model which nGen provided. So I mean, now the architects can generate nice models, but we can also generate equally good models. This is all from nGen. This is actually showing all the different floor plans. So, and this is also from nGen, which is showing you elevations and everything. So you see, this is not your usual structural engineering software, which will just do members, nodes, etc. But it gives you a full graphics for you to also do a very good presentation. Here, like I have been saying, the analysis result, the way it shows the analysis results is like really very good. Here you can see exactly in 3D the deformations of the elements in the model. This is under load combination 1, deformation Z, and as soon as you see maybe something like some extraordinary deformations, you know that maybe you made a mistake in the model or something is not going right. This is the displacement X under a seismic load for this 13-story building with a flat slab configuration. Here you see the shear walls correctly designed. This is the flat slabs design, the columns totally designed, and the good thing is you can export your results to STAAD. I use STAAD quite well, and I always want to check my results. So normally I will use STAAD as well to check whatever is done in Mydas Engine. So you can see the difference. I mean, you can see how rich this graphics is. Well, you can see how maybe accurate this can be. So this is a dynamic report which you get when you use the report maker in Mydas Engine. The reports you see here, it's very concise, and it gives you the code, the line by line code, so you can take the report, read it, and understand really what is happening. This is a table to show you all the design results. Now you can get a comprehensive bill of quantities which is exported to Microsoft Excel. So as you can see here, every member shows you the section and everything, and by the time you finish, you have your bill of materials for the foundation, for the RC members, and this is okay. Next up, we go to some fun. So after this is done, we can print our 3D models for fun. So the good thing is, right from Mydas drawing and right from Mydas Engine, you can generate your 3D model ready to be printed. There is not much to do. So 3D model from nGen is exported to SketchUp, and then you can export this to STL. If you don't have SketchUp or you don't want to use SketchUp, you can actually export this to a Parasolid file, and from Parasolid you can still send it to the STL format. And then I am using a Prusa i3 Mark III and 3D printer, so I'll use the Prusa slicer to slice my model, export it to a G code, and it will be sent to a 3D printer. The model was sent directly from Mydas drawing into SketchUp was exported into an STL file and is loaded into the slicer software. So this is just a simulation of how the 3D printing will work out. So as you can see, it's just printing layer by layer, layer by layer, layer by layer. So now what you do is you model, you analyze, you design, and you can 3D print. So here you can see the 3D printing, actual 3D printing. So this is a 3D printer. It's the print volume is 200 cm, 200 mm by 200 mm by 200 mm. So that's the biggest size you can print. Of course, you can print it in bits and glue them to be a bigger. So this is a filament, and then it prints through. So as you can see here, this is like the final model printed. This is the final model printed. So this was the 13 story. This is my first print, 13 story, and then printed, and then it can be used for presentation. Okay, next up is some 3D model analysis results by some other engineers using Mydas Engine. So this is from Engineer F. Yorson and Engineer K. Muswansa. They did it for structural construction service. So this is I think a 14-story building with a swimming pool, and here Mydas Engine has a special feature. It's called a plate beam, where you can use to model this wall. It's like a beam, but it's a plate. So, and then the swimming pool comes up neatly and nicely. So this is the model. As you can see, the model is very rich in graphics. It's really very rich. I have not seen any program which come close to the graphic richness in Mydas than Mydas Engine. This is the analysis, result of the analysis, and this is the displacement, where again you can see clearly any problems that you had drawing your modeling. This is a 3D model done by a student who maybe within a month, or in fact actually weeks, was able to do this all in Mydas Engine, and most of it was by phone conversations, but then a very good student and then brilliant one. And then he did this, and that was it was for his civil engineering design project. And then after that it was 3D printed, and guess what, of course it was adjudged the best project for that particular subject. So here you can see everything is modeled nicely. Everything is modeled nicely, including the underground car park and so on. This is the analysis results, and that also comes up very clearly. So this was actually the 3D printing of that model, the real 3D printing. And of course this is the final 3D printed model. So you can see again, you model, you analyze, you design, and you 3D print. Now these are some models which were done very quickly and easily in nGen as compared to other software. So you can see circular buildings here. This helical steps. This helical steps was modeled very, very easily in Mydas Engine. This was from an AutoCAD drawing, and it was quickly extruded and modeled. This water tank was modeled in maybe less than 5 minutes, and the way to do it is really very straightforward using Mydas Engine. These are still some of my spectacular models that I've said previously. So this is a circular building. What you see here is actually showing you piles. So you have, these are the springs, and now these are actually piles, and this is also even shown in your model. This I call the fire port. As you can see, it's a metal spherical frame with some futuristic design. It's just me playing around with some models. I like this. I saw this and I said, how do you model this in Mydas Engine? And trust me, this is really very straightforward to model in Mydas Engine. Maybe 5 minutes, maybe a bit more. Well, depends on your speed. But I like the name. It's called a hyperbolic paraboloid. And I want to ask the question, how easily can your current structural software model this? and not only model, analyze this. So you can see here it is analyzed, and here you can see the deformations. You can really see the deformations. So these are my, and then this one was under self-loading, was quick. So this is really nice. Well, more models. This is kind of some shell roofing, and as you can see, this is a copyright picture from the internet, and this is how I did a model in Mydas Engine. And this was done also very easily by rotation, as you can see, and then some few more tricks in Mydas Engine, but modeling this in Mydas Engine is easy. And I know you understand that doing this in another software or many other softwares is more difficult. Okay, this is my heartbeat. I call this the Malaysia Tower. It is twisted, a 30-story, and twisted by 90 degrees by the time you get there. So every floor twists by 3 degrees. I was inspired by the Cayenne Towers in Dubai, and then I saw some few videos on YouTube of someone trying to model a twisted tower using maybe other software. And then I realized the difficulty, and I said, let me try it in Mydas Engine. And this takes really very less time. What you do, you import a bit of geometry from AutoCAD, and straight you are just there. So this is awesome. This is awesome. So these are models which can be easily generated in Mydas Engine as compared to other software. So here you can actually see the elevation plan and analysis result of the Malaysia Tower. Yes, I analyzed it. So it was analyzed, and you can see the deformations on the certain loading pattern. So here you can see each slab rotating about 3 degrees per floor going in, and then these are some elevation views. Okay, so this is a very popular bridge in Ghana. It's the Adobe Bridge. I just thought I will model it for fun, and then, well, I think I did my best. It's not too bad, and it didn't take long. That is it. This will take you maybe a few minutes, and then it can be perfected. But really, Mydas Engine, it's really very easy to use in modeling, analysis, and design. So here you can see the analysis result, and you can see the animation of your displacement in the Z direction under some self-load and some fictitious vehicular loads. So I couldn't resist it, but I needed to print the Malaysia Tower. As you can see, it's being printed here, and I have it. This was also done in Mydas Engine. It's just to show you that you can model anything. So this one looks like an eggshell. So you can have a roof like this. It's an eggshell. We're getting to Val's Day when I was doing this, so I even used Mydas Engine to carve this out and show it as a Val's Day for a group of students. We were learning Mydas Engine together. But I really think that Mydas Engine is a very, very easy to use software, and then my impression is that as compared to other software, it makes you more productive, and it makes you even want to model and so on. So what can I say? That the limit of Mydas Engine is your creativity. Once you unleash your creativity, there is no limit to what you can model, analyze, and design. So with Mydas Engine, your vision becomes a structure. So thank you very much. Can be reached at my email at richardkofi@outlook.com, and then I will move on to the second part of this presentation, which I will do some few demonstrations on how to do this modeling. Thank you very much. So let us do some interesting structural analysis. This is something more for educational people, but I think it's very interesting. A few years back when we were doing structural analysis, I know we won't dare do something like this. So it's nice. I call it do something interesting with Magic nGen, not Mydas, but Magic nGen. Now what do we have? What we have is a beam under cosine loading. So I call it the cosine beam. This is a beam of length 2 pi, which is 6.283, something like that. And the beam is loaded with the cosine function. So the loading on the beam is minus 20 cos x. X is in radians, and the distance is the distance along the beam from the left hand side. So what do we have? We have at x equals 0, cos x will be 1, so the force will be minus 20. At x equals pi by 2, it's 0. At x equals 3 pi by 2, it's also 0. And at x equals 2 pi, it will be 1. Therefore, the load will be there. So as you can see, it's a loading pattern that follows the cosine function. Very interesting. Let's see how this can be done quickly in Mydas Engine. Note, we are going to consider two structures at the same time. So we are going to have support at fixed support at a quarter. So at the first quarter and the third quarter. And here we have pin support at the first quarter and then the third quarter. And we will analyze both of them at the same time. So like I was saying, you can analyze two structures simultaneously in the same model. That makes it very interesting. So straight away, we just do the modeling. I go to member and I just choose a beam. So any beam, I'm not really bothered about the section of the beam. So just like in AutoCAD, I just click, this is the origin, I click, and then this is the distance. So my distance is 2 pi. Now all I can do is I can type 2 right in the coordinate box. So I will type 2 times pi. You know, every text box in Mydas Engine takes functions. The truth is, the functions, I've not seen any documentation, but almost every function in Excel that I know also works. And this is incredible. I mean, in every text box, instead of typing values, you can type expressions and then they just take it. So you can see now it's formed, and you can check the length of this beam. So when you click on it, you can see the geometry. You can see now the length is 6.2832, which is 2 pi. I mean, it's incredible to have a text box accepting functions. In fact, if this length wasn't correct, I could have just typed the function right here in this geometry property box, and that would be fine. So that's what I have. Now I need to put on my load. So that's a very interesting thing. How do I put on the cosine function? That's the thing. So I go to load, right? And this is beam load. So with the beam load, I just take uniform, everything is set. I click on it, right? And then I just decide for my function. Let me change the unit to kilonewtons. And then I just choose a function, which is also something incredible in Mydas Engine. I don't see any program with such functionality. So I just do add, and now I have to define my function. So my function starts from x equals 0 to x equals 2 times pi, right? And then I'm incrementing it in, let's say, pi divided by maybe 20, right? And then I have to write a function out. So my function is cos of this should be in degrees. It's cos of degrees, but this is in radians. I have to convert it. So cos degree x, right? So that's it. That's the function. Cos of degree x start from 0 to 2 pi, and it's the spacing of pi by 2. I just do calculate, and that's it. I have my function. You get it? I mean, this is incredible. It's very, very incredible. So I go here. My function is defined. I need to give my uniform weight of minus 20, and I choose the function. So that's the function. Now you can see the function is behaving very odd here, but that's okay because it is just dividing this into 4, but we will sort that one out very soon. So I just click OK, and then to sort it out, I will just intentionally divide this beam into 20, and then you see our function. So I click this to divide it. I go on to member and I go to split. So split, I want to split in a ratio. So ratio, and I want to divide it the whole length into 20. So I just do 20 at 1 over 20. It means I'm doing it 20 at 1 over 20 so that I get the whole. This is the ratio. So this is also very incredible. And you can see I didn't do the 1 over 20 as 0.05. I just type 1 over 20 and I just do apply, and then bam, you see your cosine function right on the beam. This is incredible. I mean, this is how maybe you will want to define earth pressures, water pressures, and or you can actually define functions to do that. And now once that is done, we can actually trick the program. I can now go select everything, that is my beams, and now I can merge the beams. See, 1D merge, and it's merged. It's merged, but because my loads have been done already, they are not going to be. So I have my beam, I've not divided into 20, it's still done. But I want to divide my beams into 4 parts so that I can have exactly where to put my support. I hope you remember that. So quickly, I just go to member. I go again to divide a split, and then I select my member. I go again to ratio. In this case, I want to divide it into 4, so I type 4 at 1/4, but I can do 0.25. It's the same, 0.25, so that it's divided exactly into 4. So 0.25, 0.25, 0.25 is a quarter of it, correct? And then I just do apply. Now I can put my support here. So what do? I just go to boundary support. That's it. So this is my fixed support. So what I have, I select. So I select 1 and 2. Done. So that's all correct. So I'm really already ready to actually analyze this. But I want to copy this model up and then put here the pin support so that I can actually see how both of them are going to run. So to do that, I go to member, copy, I select everything, and then you see this. That's a very nice. So it means when I'm moving it, it moves up. So I want to copy it. Let's say 5 up, so maybe 4. It doesn't matter. Okay, then I just do apply. So this model has been copied here, but I need to change the support here. So what I do is I actually go into my analysis. I go to support, set support, and this is my support. So I just modify it, and then the first one, as you can see, it's 4 of them. So I take this and this off. Then I have only 2. So okay, now I don't have any support here. Then now I can create new support. So I just go to boundary support. It's not the same support set. Then here I just can use pinned, but we don't want to get errors, so we will make sure that this cannot be rotated. Only rotation about Y is allowed. X and this is not allowed. Otherwise you will get some errors, just errors, not really anything. So I can now put this here and then here. So as you can see, what I have here is a fixed support, and what I have here is actually a pinned. It's let's say user defined, because I am not allowing rotations. I'm allowing rotation only about the Y, which is surely what the pin means. So I just do okay. Now I'm ready to run my analysis. If this load is kind of getting in my way, I can right click and choose hide all labels, and everything is there. You can right click and bring it back, and everything is back. This is interesting. I mean, look, when you open a program for the first time, you think you are in maybe funny, but you would think you're in AutoCAD. The user interface is really very exciting, and the feel is not like your ordinary structure analysis program. It's really very graphical, and the graphics is very rich. So on the analysis, I'll go to my analysis settings, and because of the distributed forces under my meshes, I don't want maybe divisions to be 1. I want to maybe do 5 divisions in the 1D, so that every beam will be divided into 5, and then I can see my my forces will come out very nicely. So I just do okay. Let me just take off the loads, and then now I'm ready to run my analysis. I'll save this. So I'm gonna save this as I'm saving it in our webinar files. So I'll call this cosine beams. I just click my save. Now I'm ready to run analysis. So I click analysis, and the analysis runs. Well, my computer is quite fast, so this will run hopefully very quickly. But don't forget, it's running two at the same time. Okay, so that's it. Analysis is done, and we are ready to investigate. So this is what I talk about. So here I come here and I go to deformation Z. Now if you look at the deform, you see it is beautiful. It's just beautiful. I mean, you see the way the deformation, of course this is very much exaggerated, and if you want to see the rail, you can click here and see the rail. So I can look at this in the front view. I mean, maybe the rail is too small, so I can just say 0.5, and then you can see. So here I can see all of it. I can actually show my labels if I want. This is my support and my load. Let me just take my loads off and leave the support. I can actually come here. So this is a tree menu where you can turn things on and off, and then it's really very comfortable in it to use it. So you see what I have. So here you can see. So I have 2 structures on the same loading, different support conditions, and you see how the deformations are. If you look at the deformations in millimeter, Of course, straight away you can see when you see a value, you see that the maximum deformation is minus 52. Of course, you can decide to show all, and then you can see them. So you can see symmetry is assured. The deformation, the maximum deformation in this is minus 7.6, and this is minus 52. I mean, the interesting thing is you can actually select this whole thing, right click and choose hide, and straight away you can see how this has deformed much better, in a much better scale, better scale. So having two structures that you can hide one at any time, you can bring it back, I can right click, show hide all members, and they are here. So you can imagine, I mean, what we have now is we are able to investigate the effect of a cosine loading on a beam. I mean, incredible. And it was done, as you can see, in minutes. So I go back to result, but this is where what I like. Look at the reactions, and then let's think about what it is saying. You see? So you can look at it. It says what? I'm turning off deformation. It says the reaction on the vertical reaction on the support is 0. So what does it mean? It means that basically, that is my mind, this beam, if you put a cosine load on a beam and you support it and later move the support, the beam should be able to hang up because the reactions are 0. You understand? I mean, this is exciting, and this has to be investigated. This is really exciting. You cannot do this with, I mean, maybe hand calculation, and many structural software will not allow you to really investigate it in this nice way. Look at the applied forces on it. I mean, I just do forces Z and then look at it. So you see everywhere how the forces are applied, and you can see both are applied the same, because of course the loading is the same, and then everything is the same, but because of the support you get something different. Now let's go look at the beam forces. Interesting phenomenon we are going to see. If you look at the bending moment of Y, look at that. I mean, I can go to by member and I choose maybe minimum maximum. So I look at it like this, and then maybe this I can turn them into meter so that I don't have very big values. But that's it. By member min max, or by member, let's use absolute maximum. Then you see them. This is really exciting. You can actually change the scale here ×4. Now look, this is your bending moment diagram. Your bending moment on your bending moment about the Y. You see, and this one reminds me of your normal probability curve. I mean, that is when you do statistics. And look at the way this is different. This is symmetrical as it should be, and this is a beautiful bending moment diagram. I mean, what I'm trying to say is you can use Mydas Engine to really understand structures, learn it, and feel it. I mean, look, how will you know that the reactions on this is 0 and all that? And what does it mean to you? You know, and then just by changing the support, look at what is happening. Yes, of course, it's obvious that this member will be more stiffer than this because this has a fixed support on this side and this are pin support. Look, let's look at our shear of Z. Look at that. What does it remind you? This reminds you of a sine curve, right? Yes. So it's like you have our 0 here. This is our pi by 2. This is our pi, and this is our 2 pi. I mean, this is incredible. But surprisingly, or maybe not surprisingly, the shear forces diagram is the same, irrespective of the model. So you can actually go on and on about this, and you will be surprised how you will like it. I mean, it's really interesting. You can look at your beam stresses, maybe your von Mises stresses on your beams, and then see again, as you can see, the beam stresses. This is the unit here is if you make this Newton and you make this millimeter, then it's like a megapascal. So you can see that this beam is very stressed, 354 MPa, and this has maybe a maximum of 182. So you can imagine this is a beam that can hold on its own without support because the reactions are 0, but it's very much stressed. But can we really put a cosine loading pattern on a beam? That is something which is very subjective. So that is what I have for the cosine loading. It's just something for you to enjoy, and I hope you will investigate how to use functions in Mydas Engine. Thank you. Okay, thank you very much. We'll now look at the ramp to multi-story car park. I call it quick with Mydas Engine. So this is a very simple ramp. So what I have is a 25-meter ramp, and then a circular curve here of the outer radius is 15, the inner is 7.5, so it gives a width of 7.5 right here. And here you can see that it's a 6% slope up, and then 6% here, and then this is a variable gradient. But what you have is Z is 1.5 here, and then it's 3.3 here, and then it's 4.48 here. So I mean, how would you do this? If you have to do this in any other structural software, trust me, you need to start to think about how to get coordinates, how to see the way it's going to be measured, and you normally start with some point and then and so on and so forth. Here you will see how we go about it, and trust me, it's really very easy. Let us just try and get the geometry again. Outer radius is what, 15, inner radius is 7.5, and then this is 25. That's all. And then the height, we'll come back to this if need be. So I open my program. This time it's already ready. So the first thing I do is I'm just trying to do the model. So I go to plane mode. So I click here and I choose plane mode. So I'm in my X plane mode. You get it, X plane mode. So for the first I'll do is I'll need to draw the arc. I go to body. I'm going to use the body tool, and I go to arc. So I draw an arc with a center. So arc with center. And then because it's a semicircle, I click, and then I know the radius was 15. So you see I can type the 15, but I can also move to 15. What I need is 7.5, 15, sorry. So yes, the radius was 15. So 15, and then look, look at that. I mean, this is incredible. So my arc is drawn, that's all. That's like drawing in AutoCAD. I'm always mentioning AutoCAD because, well, that is the drawing tool we know. After that, I can actually offset this by 7.5. So I just go to offset. I choose that, but I want to offset it inside. So I do this and I type here minus 7.5, right? Minus 7.5, and then that's it. It's done. Okay. So I now have to draw my other line. So I just take line now and I'm drawing. So I go here, I click, I go this way. I need to go 25. You know, sometimes you should get this. If you're not getting it, when you click this, it comes back. Yeah, F8, and then you see you type, you do F8 again. Now you can see if it comes back. It's a small glitch in the program, I think. So it's 25. I'm just typing 25 on the keyboard. I press enter. Of course, I need to come down here 7.5. So I can do 7.5. I'm just choosing the direction, and I come here 25. Then that's it. I can actually copy all this onto here, which is very easy. Maybe I should do that. So I just take this, and I can just copy. I will just select 2 points. So 2 points is I'm selecting here, and then I'm selecting here. Then it's copied. That's all. So that is my ramp in plan done. My ramp in plan done. So now I need to raise it. You remember this was 1.5, this was 3.3, and this was what, 4.8. So I know that first I'll create a face of this. I just do face. I can actually select all this, and then the face is created. This face will now come to turn into slabs for me. So what I have, one slab here, another slab, and another slab. What I can do now is I can actually select them like this, right? It's selected, and I do convert to member. This is incredible. I mean, you just select a face and you convert to a member. You could have brought this from AutoCAD, by the way, but I think even drawing in Mydas Engine is easier. I think so. Now I just go to slab, and then I can choose plate in out, which I'm sure it will be explained. And this is with a thickness of, let's say, 300. I just say okay, and then that's it. So my slab is formed. It's formed. Now I need to move it up. So first of all, I know this is 1 point. This starts from 0 to 1.5. This starts from 1.5 to 3.3, and this starts from 3.3 to what? 4.8. So first and foremost, I can click this and I do move. So I'm moving it up to, I'm in plane. So that's what I see here. I have to go into 3D mode. Sorry. So I click this and I do move. I go here and then I can move this. I can move this 1.5. So I do 1.5 and then it's done here. And this, I will move it up to 3.3. So I do this and I'm moving this to 3.3, right? So I just do apply. Now, interesting, I need to move this one face here up to this, and this up to this, and then my ramp is done, right? So this is really just a breeze. It's just something very not much documented, but it's interesting. All you have to do is just draw a line and then use it to do the movement. So what I'm doing is I'm taking line and I'm drawing one here, because this is why I should move to the 4.8. So one, and then here. Make sure it snaps. Then I press escape. I have to draw another one here. I press control. I'm turning it around. So I'm drawing the line again. So this and that, correct? And then the last one, just press again. I'm drawing the line here. So I have this and that. Now I'm almost done, actually. I'm almost done. So here I go now to move. I use move. And now I move this line here, and then it will move the slab. So I just do select object. My aim is to just select the line. That's the thing. So you have to try and select the line. So the line is selected, and then I go this way. Look at that. So I have to move it 1.5. Do you remember? So 1.5. If I'm not getting it, I just come here, then I just type 1.5. Then that's it. It's sorted out. Here, I'll move the one here, 4.8. Here, I have to get a line. You can actually use filters to get it, but fine. Here, I go up, and then I do another 1.5 again, so that gives me the 4.8, yes, and then I just do apply. And then finally the arc is tricky, but it's almost the same way. Got it. So I move it up. See, it's so much wonderful that I got I have to go 1. No, I need to go with the arc. I need to go 1.8 because it's 1.5 to 3.3, so I need to go 1.8. Good. So I just do apply, and then that's it. You see, my ramp is formed. I mean, this is incredible. This is so good. So I actually use this to do a car park. I'll just click on the file so that you have a look at it. So you can see what I did was I copied it up 4.85 times. So you see, your car enters here, it comes to the next floor. There is a park somewhere here. I mean, some flat slab. It's somewhere hidden here. I was just playing around with it. So if you do the slab, I think it's somewhere here, flat slab. Yes, you see them here, but it's not something I want to use, so that's fine. So you can see, so it's not just that, but I have seen some programs and people trying to do ramps, and trust me, sometimes I can see it's frustrating. But with Mydas Engine, everything it's so easy. You see how this is divided. This is also very easy. I mean, we don't have too much time in this webinar, but I'll be very glad to fill you in on how this was done. Thank you very much. Now we go to the next one. Hello there once again. So the next stop is we're trying to model a tunnel on a motorway. We want to do it in minutes with Mydas Engine. Well, this is just your normal box culvert, but it's really for a car rather than maybe water passage. So what is this? It has a length of 30 meters and a width of 8 meters, and it has this wing walls at an angle of 60 degrees, and the length is 5. So that's about, and the height is 4 meters, and the wing wall has 2 meter this way and then 4 meter at where that is. So that's about it. Let's go into nGen and see how we can model this quickly. Again, we go into the plane mode. So again, I just choose my YX plane. I click this and I just choose plane mode. So I start with a line. That is about the fastest and the easiest. So I click line. I'm drawing my 30 meter line. So I click and then my 30 meters. So 30 meters is done. I need to draw my wing wall. It was at an angle of 60 and it's 5 meters. You remember? So I click line and I'm drawing. Now this is 90 degrees. So I take off the 90 and then I move this way. But you can see what I have is XY. I can actually change this to the angle and length. So it's really very simple. So here I tap 5 for the length, and then I go to tab and type 60, and then that's it. So I just press enter, and then that's all. I'm done. I can do the same thing here, or I can actually mirror. And let me use the mirror function. I click mirror. I click this. I do copy, and I do select 2 points. So I select the midpoint of this, and then I go straight. I check 90 degrees. I go straight, and then it's mirrored. Then I just press enter, and then that's it. So I don't have to do it again. So then that's it. I can actually mirror this also. The length was 8 meters, if you remember. So I can go to line this. I just go 8 meters, 8 meters, and then that's it. Okay, so now I can mirror the whole of this. I choose this, and then I go to mirror. Now my mirror line will be the midpoint of this, anywhere this, and then I just do apply, and then that's it. So it's formed in plan. It's formed in plan. And now I can look at it in 3D like this. That's it. So that's my curvating plan. Now that is the nGen magic for you. Quickly, I will use this 3D modeling tools I've been talking about. So I just click everything, 1, 2, 3, 4. Of course, I can select it like this as well. I mean, yes. And then I just go to extrude. It's already showing me the direction. I just extrude it up. Beautiful. I just go 4 meters, so 4, and then it's applied, and then that's all. So I need to extrude this, but I don't want to go this way. I want to go in a different axis. So I do this, and then I can extrude this 30 meters. So I just do 30, and then that's applied. Now I can actually draw a new line and extrude that one as well. Line, this, and then I will use extrude again. I click this. It's no. I click this line. Yes, but I need to change the direction to the x-axis, and then I pull it, and then I just type 30. Then it's applied. So basically it is formed. Now I need to just convert the faces to members. I click it like that, and I can choose convert to member, right? And then here I'll choose a plate, axial plus flexure, and maybe T300, and okay. Yes, I know you say that, what about this and this? Now that is even the easiest thing to do. But first things first, I mean, I'll just go to you go to member and you go to something they call dimension. So I click dimension and then I dimension here. You see, this is showing you that the length from this way up to this way is 4 meters. Now I want to change it, but from the top. So I click this so that the arrow changes. No, the arrow changes up, something like that. Then I just double click this figure and then I type 2 and I press enter and then bam, I have it. You know, it's really exciting the way this works. So exciting. I can do the same thing here. You see, this one shows that it wants to decrease from the down. So I click again so that it goes up and then I just do 2 and then again I just do that. You see, so that is exciting. That is really, really exciting. Actually, I could have done it another way, but let me just use this. So I just do dimension, same way. I click. I could have mirrored and all that. So this is 2, and then again, and then last one is this one. It's this one. So that's it. So as you can see, I have my culvert. I can actually display it, name view, surround view, and then at least you can see the way it's done. Can actually play it a bit, surround view. Yes, so that's it. So that is your tunnel under the motorway model in minutes, under minutes. Don't forget, if you want to analyze this, and there's not much to do, meshing is automatic, everything, or if you have to put just your loading right, and then you are really on your way to analysis and design. That's all. Thank you very much. We see you in the next lesson. The next modeling will be the elevated water tank model and the bonus cooling tower model. What we need for the cooling tower is just 3 coordinates, which we will use to draw the arc. And what we need for this cooling tower is just 6 coordinates. Let us do the cooling tower first and see how modeling this seemingly complex structure as easy as it can be in Mydas Engine. So we go into Mydas Engine and again we start. So we start in the plane. In this case, I will be in the ZX plane. I click and I'm in the plane. I need to put in my 3 points. Don't forget the point: 4500, 2590, and 22.570. So I just go to body and I just do points. So I can actually look for the point or type the point. So in this case, I type 45 and tab 0, right? And I press enter. So that's the point somewhere formed. The next point is 25 and tab 90. That's the next point is formed. And then the last point is 22.5, 22.5, and then 70. That's it. Then I can press escape to quit this command. I have to just draw the arc of this. So the arc, if you want to draw the arc, you draw with the first point, the last point, and then the middle. Don't do first, second, third. It's the first and then the last before the middle. So I now go to arc 3 points. I can start from the top as well, doesn't matter. But the first, second, and then I just choose the third. So my arc is formed, as you can see, and then I'm ready to do my cooling tower. Now there is some option that you should know. First, you have to be able to revolve, you have to be in 3D, and then there is this option which is also not too documented, but is in the global settings. So the global setting will tell you that in modeling, when you split revolve faces, normally split into 2, so it's 180 degrees. That is the default, but you can come here and change it to 10 or 5 or 20. It means when I revolve something 360 degrees, I'll get 36 divisions. So if you want to get maybe a very good mesh, or you want to follow a particular mesh, you do it. But you don't need to do this because the meshes can be done for you automatically. But yes, if you understand the meshing, you can also do your own mesh as you wish. So when I just say okay now, well, whatever, it says some temporary folder, not okay. I mean, because I just did that, so just telling you something. Okay, so I mean, this is just by the way. So I just say okay now. Okay, so now I have to just revolve this. I go to body, and I go to this very great tools here, the 3D modeling tools. I go to revolve, and then I select the object, which is my arc, and then my axis of revolution is of course this, and then I just revolve it like that. You see, I mean, so I have to revolve it the whole 360, so 360, and I just do apply, and then that's it. And then my this thing is formed. You can see. So once my cooling tower is formed, now I can convert this. I can convert this into member. So I just do convert to member, and then I choose a face, and I choose shell. Maybe I choose 300 again, and then in this case I just select this, and I just say okay, and then bam, I have my shell formed. So you can see this is formed as nicely as it can be. You ask me, what about if you want to divide it also vertically? Now there is a trick that I will share with you here. What you are going to use is you are going to do some extrusion, and then it will cut for you automatically. Okay, so for me to do that, I'll go into my plane mode again. My plane mode here, in this case, I just do this and I'm in the plane mode. So I'm right in the plane mode. I'm going to just draw a line through this on this plane. So I line maybe from here up to here. That's it. That's it. And then let's say I want to do it. This is 90 meters total. I want to divide this into 20. So 90 by 20, that gives you 4.5 meters, correct? Okay, so I can copy this line 4.5 meters up. So I can just say copy, and then I do this. I'm not in 3D, I have to be in 3D definitely. So this, I do copy, I go this way, and I'm going up. You see, I'm going up. So I'll do it 20 at 4.5 times. 4.5 at 20 times, and I just do apply. So you can see I have all my lines here, right? Have my lines. Now I'm going to extrude the lines, and the lines will be planes, and then I can use it for cutting. So whilst I'm here, I can actually go to extrude, and then I'll select the lines here like that. You see, it's selected, and then it wants to extrude up, but I want to extrude in this direction, this way, and I want to extrude it symmetrically. There is so many options, and I want it to cut everything it makes, and I want it to delete after it has finished cutting. So I just do this like this. Now I just do apply, and then it is cut, deleted, and then I have all my meshes. So this is wonderful. As you can see, this is really wonderful. It is not a feature which is well advertised, but nGen has a lot of surprises. I mean, you can't even know the next surprise, because it really has so many features that it's not maybe very well documented, but this is it. So as you can see, I have my cooling tower already made, and this is like really good. I actually have done this previously. It's not like it's just the modeling. We have done the analysis. So here you can see I have the cooling tower. This is even not meshed, and this one I actually, instead of using shell, I use plates. So that one I revolved it, but I just did some divisions. That's a more complex modeling, but not that difficult. But this has been analyzed, so it is easy. I'll just go into the analysis, right? I'll hide this for the meantime, and then you can actually look at the analysis. This mesh was automatically done by the program. It means I didn't have to divide anything. The mesh was done. I just had to set it from the analysis sub menu. When you go here and you go to analysis setting and you go to mesh, you just choose the length. So here I said the length of the mesh I want is 2 meters, and it can do triangular and quadrilateral meshes. You get it? So it's really, really good. This one, what we actually did was, you can actually see the loading here. What I have is a unit load right at the tip. I was actually investigating the buckling of this cooling tower, and that's, so I was looking at the modal and eigenvalues and of the buckling modes, and then here you can just check them out. So that is it. So these are the deformations. You can actually see the deformations here. You see, so that's the first, the second mode. Maybe this is the fifth mode. Of course, you can just do the animation also for you to actually see how this how good this is. Get it? So this is actually showing you the buckling mode of this particular cooling tower. So at the 8th buckling mode, the eigenvalue is 3.15. So if you multiply it by the unit load here, and then that will give you the buckling load for this cooling tower. So it's not just the analysis, it's not just the modeling. You can actually perform analysis and so on. So it's really a very easy to use software, and it's really very good. We will move on to modeling the water tank in just a minute. Well, for the water tank, the coordinate is already in the Excel spreadsheet, so you can select it like this and you copy it. Now I come into my Mydas Engine. The first thing I do is I go to tables and I see body and I have point. I double click it and I can actually here make sure that's for the X, and then you just do paste, so you can see that the point have been formed here. So those are the points already on your screen. So that's how easy it is. X and then Y and Z. Now I can actually come back to my modeling mode. I can close this, come back to my modeling mode. I can actually be in my plane mode, and then I can see all my points. I can see all my points. So it's 0 0, and then if you remember the way the section was this, so you can see it, and you can actually see it. So what we are going to do is we are going to draw. Now we have everything, so we just draw. So I'm here, line, and then I take my 90 off, so I'm like that. There's another one like this, like that, like that, and then there is from here to here, definitely. And then of course you see this didn't go right, so this one didn't go right. Actually I can actually extend this by holding it and dragging it like that, just like in AutoCAD, so you can stretch. And then I'm in my 3D. I can go into my 3D mode. What I have to do is I'm going to revolve about this axis, about this vertical axis. So, and before that, I'll go to my options, my global settings. If you remember that, I'm going to change the divisions. The division, this is still 180. Maybe I'll just do it 20, so that it's 360 will be split up into how many times? 360 over 20 is 18 times. Yes, I think that's fine. So that's good. So that's it. Then I go to body and I go to revolve, right? So I will revolve this too, and then this, and then this. The axis, we need to draw the axis. So as you can see, we don't have the axis, so we have to just draw the temporary axis. It is a vertical line. I'll make sure this is 90 degrees through this. So it's a vertical line through this. Okay, so that's it. It's a temporary axis. I can actually hold it and maybe drag it much further, so that it's, or if I want to, I can actually change the Z coordinate here. So I can say the Z coordinate is 40, and then straight away you go. The other Z coordinate here, I can say 0, and then it's a straight line. So you can actually change the properties of members and everything in the geometry tab. Now I go to revolve and I select what I want to revolve. Now I have to select the axis this way, and then I have to drag it. You see, sometimes you get that. It's just that I don't know, maybe it's a glitch in the program, but I realize maybe if you select them just a bit at a time, it works. See it's working now. So this one goes to 360 degrees, and then you do apply, and then you do the other one as well. So that's for this one, and this one the axis is this, and then you do it like that. Also 360 degrees, and just do apply. Okay, so that's the tank already done. I can of course select this. You know what I do now? I just select this like this, and then go to convert to members, and then I can convert to the member. I want to do it one step at a time, so I need to take this, for instance, taking this, and I'll convert that to wall, and maybe I'll just take this also. That's another different one. So if you realize this is kind of together, so but that's fine. So I just take this, convert to member, and then I do face, and I do shell, and I do 300, and I do OK. It's not selected. So now OK. So it's done now. I can actually convert this to walls. That's what I wanted to do. This one now, this shell, I want to convert this into a wall, because it can do circular wall. So that's it. And then whatever is down, I'll also convert it into this. I'll also convert to member, and then I try plate or slab. If I won't work, I know, because it won't work because it's a circular. So I do shell again, and then let's say 300, and I do okay, and it works. Of course, now I can take this and convert this only into a slab. This is a slab, so now it works. So I have a slab, a wall, and some shells. This is a shell because it has a circular edge here, so you can't change it. Now what I have to do is I need to change this. So this, I have to convert this also. So I take this, right, and I do convert, and now that one is converted into a column. So I choose column, and let's say I will just choose this SR column, the circular column, and then that's also done here. So I need to send this column round. I need to rotate this column and 5 more times at 60 degrees, right, so that I get 6. 6 is 36. So I just choose rotate, and I choose my column. It's going to rotate here, but of course I want to rotate it here, so I pull this thing here, right here, like that, or it can be anywhere on this axis. I'll use copy option, and I'll do 5 at 60, 5 at 60, and as you can see, wow, it's done. It's done. So you can see this is really done. Now what I need to do is I need to draw my beams, the beams which is linking the linking of the columns. I can actually go this way. I need to divide it into 3, so I just select this, right? I mean, I can select only the columns. So these 2 columns, so these 6 columns are all selected now, and I'll split it. So I go to split, and then I'll split it by ratio, and then I want to split it into 3, so it will be 3 at 1/3. Don't just do 0.33. Then 1/3 is perfect because it just calculates. Like I told you, these text boxes knows mathematical expressions. Incredible. So I just do okay. So that's split. Now I can draw my beams. So I can now just go to member beam, and then here I just choose the beam, maybe 500 by 500. I mean, normally I would know, and then I just draw like that. That's all. Okay, so this is a 90 degrees, so it could be a problem. So if you take the 90 off, like that, it snaps. Correct. I think this didn't draw. Okay, it did. Then I draw again. This case from here to here to here. Nope, no problem. It snapped. I can just draw again. Yes, and I can draw run right down here as well. I mean, so as you can see, our water tank has been formed, and that one was just a minute. Now this has been done previously by me, so that was it. As you can see, this one was rotated without divisions, but this I've done it with some divisions. But I did another model of the water tank actually using plates instead of shells, so that it can be designed in Mydas Engine. Mydas Engine doesn't support shell design as at the moment, but I hear it's going to be very soon. It will be designing it. But if you want the analysis, yes, of course you can do it. So this has been designed and done already. So as you can see, the model is it's not too much different from the other one, but the design has been done already. So you can see the meshes, and these meshes were formed automatically from that. So you can look at the deformations. You can look at the deformations on the self-loading. So you can see that the maximum deformation, for instance, is -4 millimeter. Means that, well, the structure is rigid, at least on the self-loading. But I've done some other load cases. If you look at the hydro load cases, for instance, displacement X, Y, Z, displacement X is okay, displacement Y, that's fine. But what I want you to look at is this wind load. Wind load, the deformation, displacement in the Y is fine, displacement in the X. Displacement in the X is very not too good. So this is about 60 millimeter, 6 cm. And you can see that although this is exaggerated, it could be, the reason could be that you don't have this link beams under this. So once you put them there, maybe that displacement will be better, so that even before you go do your design, from your analysis result, you can even change a few things before. So it's really okay. You can look at your beam stresses under the hydro load, for instance, because that's the biggest. So here I'm under my beam stresses. I'll look at my von Mises stresses, not the beam, sorry, the plate stresses. The plate stresses under von Mises. So what I want is von Mises tensile. You can see from here what's happening. If you go to Newton, then you can see that, well, they are not that huge. It's in the region of 20 megapascal. Means using reinforcement, you could actually get them sorted out. So that is in reality a very good experience with Mydas Engine. Yeah, the graphics is stunning, and every time you see everything as it should be. So that was for the water tank, and you saw it didn't take that long to model. Thank you very much.